In this video, I will explain how the data filters work. This is a new feature we have added in the 2020 version that allows you to filter your dataset in order to work on only part of it. The filters are available in Data Explorer, PicAnalytics, and Monolix. Today, I will show filters with only one condition, and in the next video, we will see how to do combinations. The dataset I will use is a PKPD dataset with columns ID, time, amount, administration identifier with the number 1 for IV doses and number 2 for all doses, DV, DVID, which distinguishes the PK and the PD observations, a column sense with zeros and 1 to mark sensor data, study, and weight. I will load this dataset into Monolix and accept it. And let's have a quick look at the plots. If I stratify by study, I can see the study 101 with a single oral dose, study 102 with a single IV dose, and study 201 with multiple doses, first an IV loading dose followed by multiple oral doses. The sensor data are shown as red dots, and I also have the PD data. If I go back to the data tab, the filters are here, but for the moment they are grayed out. To use the filters, I first need to choose a model. So I will go to the PK library and choose a simple model. When I go back to the data tab, the filters are not available. Before I use them, I'm going to add an additional covariate that will be the dosing design. This adds a column with single or multiple doses as a design. Now let's go to the filters. Here I see my current dataset. To filter it, I need to click on it and create a child, which will be the filtered dataset. I will first explain the general syntax and then show you several examples. The dataset can be filtered by either selecting IDs, selecting lines, removing IDs or removing lines that correspond to a condition. When working on lines, we keep or remove the lines corresponding to the condition, and when we work on IDs, we keep or remove the IDs for which at least one line corresponds to the condition. The condition is defined by selecting a header. The headers correspond to all the headers of the dataset, including also the additional covariates, plus a few additional ones. Here I have the ID index, which is 1 for the first individual, 2 for the second individual, etc. This is convenient to select only the first 10 individuals, for instance. And similarly, I have the line numbers. In this example, I can notice that for the DV, I have 2, 1 for each observation identifier. This is because when filtering based on the content of the DV column, it usually doesn't make sense to apply the same threshold on both the PK and the PD values, so they are automatically separated. The next column is an operator. If I choose a header which can take any value, for example, if I choose time or weight, then the operator can be equal, different, larger or equal, larger, smaller or equal, or smaller. And then in the last column, I indicate the threshold value. If I have chosen a header which can take only a few values, for example, study, then the operator is equal or different, and in the last column I have a drop down which indicates the possible values. The ID column is considered as continuous if it has only integers and categorical if it contains strings. As a first example, I want to filter on study to keep only study 101. So I will select IDs for which study is equal to 101. This is what I already have. Note that I could also have used select lines. In this example, it would have done exactly the same. If I click on accept, the filters will be created but not applied, meaning that the parent dataset will still be used. On the opposite, when I click accept and apply, the new filtered dataset will be used for the estimation. As some columns may become useless once the dataset is filtered, you can have warnings showing up. They are not an issue. When the filters are applied, your original dataset remains unchanged. There is no new dataset file created. The only thing we do is that we save the rules in the .mlxtrand file. I have an example here, for instance, and then we reapply these rules when reloading the MonoX project. The filtered dataset is displayed in the Data tab, and we also can check in the Observed Data plot that I now have only the data for Study 101. Now let's check a second example. It is possible to create several filtered datasets. So I will create a new child from the parent. When I start to have several filtered datasets, it is convenient to rename them. So I can give a new name to this one, and this time I would like to remove the censored data. So I will call it sense removed. To do this, I will remove the lines for which the sense column is equal to 1. When I do this, you see that in the value column, actually the values that are proposed are left censored or not censored. This is because the filters apply on what we call the interpreted dataset. The interpreted dataset is visible in the Data tab and corresponds to how Monolix has understood the data. For instance, if you have a covariate which changes over time and you have tagged it as a continuous covariate, Monolix will only use the first value for each individual, and this value will be shown on lines of the interpreted dataset. In my example, I can remove the lines for which sense is equal to left censored, corresponding to a 1 in my original dataset. And I can accept and apply. When I do this, the filters corresponding to the study are completely ignored. I'm only taking into account this one here that filters the censored data. I can check it in the plots. If I go back here, I see that I have my 3 studies, but no red dot representing the censored data anymore. As a third example now, I want to work on the PK data only. So I again create a child, and then I will select the lines for which the DVID column is equal to PK. And I apply. If I now check the filtered dataset, I see that the PD observations have been properly removed, but also the dose lines. This is because in the interpreted parent dataset, that I will show you again by applying the parent dataset, so that's again the parent, we see that we have no information in the DVID column for dose line, because this is irrelevant. And this is the case even if in my original dataset I had put PK on those lines. So Monolix really works on the interpreted dataset that you can always see in the Data tab here. So for my filter to filter the PK part of the dataset only, I need to proceed differently. So I will go back to this filter, and I need to proceed the other way around. And instead of keeping lines, I will remove some lines. So I will remove the lines for which DVID is equal to the PD. And if this time I accept the dataset, we see that in the filtered dataset, we have the dose lines and the PK data, but no PD. And this is what we want. And as a final example, I now want to filter based on the ADM ID column. So let's again create a new child, and this time I will filter based on ADM ID, and I will choose to select the IDs for which ADM ID is equal to 1, corresponding to the IV. When I do this, all individuals which have at least one dose tagged with ADM ID equals 1 will be selected. So this includes the individuals which have an IV single dose, and those who have received the IV loading dose first and then the oral doses. If I accept and apply, I can check this in the plots. If I split by study, I see that I have only those 2 studies, corresponding to the individuals which have at least 1 IV dose. In this video, I have done simple filters. More complex filters using unions and intersections will be the topic of the next video. Have a nice week and stay safe.